Hello, Pandemic Pre-Calculus. I hope you're well. If you're watching all these videos as a marathon, that means you've just watched 3 videos and you're about to watch the 4th. I hope you take a drink of water, stretch, take care of yourself, okay? You're doing a lot of hard work here. And I'm going to talk to you in this one about something called the end behavior of a polynomial graph. So what end behavior is talking about when I say I'm talking about the end behavior of the graph? The end behavior of a graph is what happens for a very large or very small values of x. So I want to take a look at a graph that we're familiar with on Desmos to help us understand this idea of end behavior. So this is a graph we know and love. This is our basic quadratic function. F of x is equal to x squared. Let me put it in function notation here. F of x is equal to x squared. And I'm going to pull up a table. So here we can see these points. These are the typical points you plug in. Very normal. But what happens if I put in a very large number? What happens if I put in, I don't know, 100? Well, my output of the function is then also very large. I get out a very large number. What if I put in 500? Well, I get out an even larger number. What if I put in 1,000? I get out an even larger number. So as I'm putting in larger and larger values for x, I'm getting out larger and larger values for y, for my output. My input is increasing. That means my output is increasing as well. So the way that I could write that in mathematics notation, I'll take a screenshot so I can show you right here. Because as my x values are increasing, my y values are increasing, in math notation, I could say, look, let's make it a little bit darker. As my x values are getting really huge, as they're approaching infinity, what's happening to my f of x? Well, my f of x values are also getting really large. They're also approaching infinity. And in math notation, we would call this the end behavior of the graph. And we could read this out loud by saying, as x approaches infinity, I'm pronouncing this little arrow, I'm saying approaches. As x approaches infinity, f of x approaches infinity. And that's what we would say in math notation. But we also want to see the end behavior as x becomes a really small number. So let's try like negative 100. Well, I get out a pretty large number there. I get out, what about negative 500? I get out an even larger number. Negative 1,000. You get the idea, I think. So even as x is getting smaller and smaller, even as I'm going out in the negative direction, my output is still getting bigger. My graph is still getting taller. And I'll write that for you in math notation. So in this case, we could also say, as x is getting smaller, as I'm approaching negative infinity, as I'm getting smaller and smaller and smaller, my f of x is getting larger. It's approaching positive infinity. So as x approaches negative infinity, f of x approaches positive infinity. All right. So that would be the end behavior of our good friend x squared. What happens if I asked you the end behavior of negative x squared? So let's pull up another table here. And let's take a look at what's happening. So let's start by looking at the positive side. As x is 0, I get out 0. When x is 1, I get out negative 1. When x is 10, I get negative 100. When x is, 100. So as my x values are increasing, as my x values are getting larger and larger, my output values, my y values, are getting smaller and smaller. So in this case, as x approaches infinity, f of x will approach negative infinity. What if we put in small numbers for x? What if we put in negative 1? Or negative 10? Or negative 100? Or negative 500? Or negative 1,000? So you notice as I'm getting smaller and smaller x values, as I'm putting in smaller numbers, my output is getting smaller and smaller. So as x approaches negative infinity, f of x approaches negative infinity. This is what we're talking about when we talk about the end behavior of the graph. And this can also too be useful for us when we are trying to graph. So let's summarize a little bit of what we just saw here. So for the function f of x is equal to x squared, remember that was where we were pointing up, like this. We saw that as x approaches larger and larger values of infinity, the output of the function approaches also infinity. And as x approaches negative infinity, the output of the function approached negative infinity. And we also saw for the other function example that we looked at, we saw that for f of x is equal to negative x squared. Remember, that's the parabola that opens down. Like this. Sorry about that, guys. I'm recording in my bedroom, sitting on my bed, because my baby's crying a lot in the living room, hanging out with Dad. So we said here as x approached positive infinity, f of x approached negative infinity. And as x approached negative infinity, f of x also approached negative infinity. And that was the end behavior for a quadratic function. So here's what I would like you to do before next class, before I see you guys again. I want you to use Desmos or a graphing calculator. And graph the following functions. And find their end behavior. So here are the functions I want you to take a look at. We'll say f little 0 of x. I want you to do x cubed. And g of x, I want you to do negative x cubed. And I want you to try x to the 4th. And I want you to try negative x to the 4th. And I want you to try x to the 5th. And I want you to try negative x to the 5th. And remember, this is using GeoGebra. You don't have to graph these by hand, or Desmos or GeoGebra, whichever you like. You don't have to graph these by hand. And negative x to the 6th. And what I really want you guys to do, I'm going to give you one more pair and then I'm going to stop, I swear. this one more pair. So I want you to graph these and take a look at their end behavior. And then I want you to find some patterns for me. I want you to know, what patterns do you find? So I'm expecting you to be able to bring me at least 2 patterns to class. Bring me 2 patterns. To discuss. And if you get stuck and you can't find any, head to those discussion forums and see what your classmates have to say. All right, friends, stay safe. I hope you're well, and I will see you very